Hello, my name is Vincent Cupertino, and I will be presenting electrical system failures and troubleshooting in a Piper Seminole. Today, I'll review general assumptions of electrical system failure and basic troubleshooting available for all airplanes, a brief overview of the Piper electrical system, and then some different electrical system failures that can happen in the Piper and warning signs. So first things first, um, electrical system failures is a very commonly misused phrase and almost always actually refers to alternator or voltage regulator failures. What happens in this case is the alternator is no longer capable of providing electricity to the electrical system and the battery takes charge. Should note, according to Lombardo, alternators have a TBO or time between overhaul of 1200 hours. So it is fairly uncommon for an alternator to fail. But that being said, alternator problems are especially dangerous due to the fact that if the alternator fails, the electrical system continues to operate normally as if nothing happened. The battery will immediately take over the power requirements of the system. Now, due to the failure of the alternator, the battery cannot get recharged, so any electrical demand will cause the battery to discharge. The greater the demand, the faster the battery will become exhausted, and the less amount of time you'll have with your electrical system working. Now, that is tricky if you didn't have a way to identify some of these failures. The most common way to identify system failure is by checking ammeters. Ammeters provide information about current flow. The pilot should be familiar with the type of ammeter in their aircraft and how it reacts to battery discharge, alternator failure, and loads that exceed their alternator capacity. Add the ammeter to your instrument cross-check list to avoid having an unknown electrical system failure. And also, it'd be a great idea to add a visual check of your alternator in your pre-flight. So make sure the mounting bolts are tight and clean and ensure the drive belt is properly torqued as well. All right, now that we know about some assumptions of electrical systems, electrical system failures, let's briefly review the Piper electrical system. The Piper electrical system is a negative ground, dual-fed split bus system capable of supplying sufficient current for complete night IFR equipment. Now, that being said, I'm going to concentrate on the alternators, the battery, and the emergency battery since I'm concentrating on alternator failures in today's presentation. Aircraft alternators require battery power to stimulate a magnetic field and provide current throughout the airplane's engine. While the primary responsibility of the battery is to start the airplane engine, an aircraft alternator's primary responsibilities are to supply electric power to all vital equipment on the airplane and to recharge the battery. Now, knowing that the battery's primary job is to start the engine with the use of magnetos and that the alternator is used to recharge the battery, let's talk about Piper specifics. The primary electrical power is supplied by two belt-driven 28-volt, 65 amps alternators, one mounted on each engine. The alternator provides full electrical power output even at a low engine RPM. Each alternator is protected by an alternator control unit, which incorporate a voltage regulator and an overvoltage relay. While regulators maintain effective load sharing, we are concerned with the overvoltage relay. If an alternator output exceeds 32 volts, the warning alternator failure will be activated and will take an alternator off the line. We will go over that later in some of our emergencies as well. Now, there is a 13.6 ampere hour 24 volt battery that provides current for starting the use of electrical equipment when the engines are not running and for a source of stored electrical power to back up alternator output. The electrical system also includes an emergency battery, which provides electrical power to the emergency bus during a complete electrical failure or when the electrical power from the primary system is insufficient. The emergency battery switch must be in the arm position, and power is applied to this equipment automatically after a total electrical failure. The emergency bus powers a standby instrument as well as all primary function display functions except COM2 and NAV2 for 30 minutes. The emergency battery is isolated from the emergency bus equipment by a relay which is controlled by the emergency battery switch. The emergency battery diode isolated from the electrical power generated system. All of this allows the generated system to charge the emergency battery during normal operation. Now, each alternator does have an on-off rocker switch. and overcurrent protection is provided by the 80 amp tie bus. Now, there are a lot more details to review in the Piper Seminole electrical system, but since we're talking about alternator failures today, I'll stop there and move on. If you did want more information, and even this picture is shown, it can be found in the Seminole POH. All right, we were mentioning previously about ammeters and how to check your specific aircraft's amp. So this is how you check it on the Piper Seminole. There's 3 different pages here. First, we have it on the multi-function display on the right side. You'll be able to find the amp meter check on the left side of the screen. And finally have it on the engine indication page as well. And this is more specifically what you're looking for on the left side. Now, some things to note here. The maximum alternator load on the ground is 60 amps. The maximum alternator load in flight is 65. Main battery minimum volts is 25, maximum is 32. Minimum emergency battery volts is 23.5 for flight, maximum is 32, and the minimum is 20. Now, we're going to dive into different failures that occur and different troubleshooting that we can do, mainly resetting circuit breakers. It should be noted that alternator failures during VFR conditions are not as bad as those in the SOUP or IMC conditions. Obviously, in VFR flight, you're not relying as much on the instruments. However, any alternator failure should be considered an emergency and you should land as soon as possible. So let's dive right into some electrical system failures that can happen and what we do to resolve those. So in the case of a single alternator failure, we will receive an indication, a master warning, the triple chime of the left alternator or the right alternator failure. We'll verify that failure by checking the alternator amps indication, as I just shown in the previous slide. The electrical load will reduce less than 65 amps. The failed alternator switch, whether it's right or left, will turn it off. The failed alternator field circuit breaker will then be reset, pushed back in, and the failed alternator switch will be turned on. If the alternator still failed, we'll leave that failed alternator switch off, and we will monitor the alternator amps indication. Now, a couple things to note here. Tipped circuit breakers should only be reset if the affected system is considered essential for safety of flight. Obviously, alternators are essential for the safety of flight in this case. Now, prior to resetting the circuit breaker, wait at least a minute and verify there's no smoke or burning smell. If the circuit breaker opens a second time, leave the circuit breaker out. Do not reset any non-essential breakers in flight, as I mentioned previously. All right, now for a dual alternator failure, we'll review that now. An attempt to reset the alternators, we will turn the failed alternator switches off, which is both in this case. We will reset if the circuit breakers are tripped, and we will turn those alternator switches back on. Now, if only one alternator resets, we'll turn the operating alternator switch on, the failed alternator switch off, and we will maintain less than that 65 amp electrical load. And then finally, we will monitor that ammeter. Now, if neither alternator resets, then both alternator switches will be turned off and we will electrical load and shed in less than 3 minutes. Now, load shedding is something that we do need to know the definition of as pilots. Load shedding is the ability to reduce the electrical load to the bare minimum to extend battery life. I'll tell you how to do that here in the next steps. So first thing to do is non-essential bus. We're going to pull that. That's in row 1, column 1 of the circuit breakers. We're going to pull the lightning bus circuit breaker in row 1, column 2. We're going to turn the avionics bus circuit breaker, row 1, column 3. We'll pull that as well. Turn off the avionics master switch. We're ensure that the emergency battery is verified and armed. Some other things to note here is volt indication changing to E volts on the engine indication system page. If the emergency battery does not activate automatically, we're going to ensure that the battery master, the alternator 1 and alternator 2 switches are going to be turned off, and they'll force the emergency battery to power the essential bus, which is what we want in this case if both of our alternators have failed. All right, we're going to go over 2 more potential emergencies here. So a complete electrical failure, you will have an indication that it will be on the emergency battery at this time. Um, so, right, everything has failed. The emergency battery is now powering our electrical system. So in this case, the emergency battery will be verified and armed. Standby flight instruments are going to verify they're operational. Aircraft control, we're going to use primary flight display and standby instruments. The battery master switch is off at this point. The alternate left and right switches are off as well. And prior to landing, we want to note that our landing light is inoperative. So if you are at night, we will not have a landing light. That's key to know. We will have to use the manual extension of the landing gear procedure as well. Now you have approximately 30 minutes of electrical power available. So it should be noted that in order to keep the 30 minutes of battery life, you have to limit 15 minutes of usage of pitot heat and only 3 minutes of comms, right? So you only have 3 minutes of communication. Make sure you contact air traffic control as soon as possible and get that clearance to land. Now finally, emergency battery voltage. It's master warning, triple chime, flashing red, E-volts indication on the on the EIS page. And a complete electrical failure is imminent and we need to land as soon as possible. All right. Now today we reviewed electrical system failures and troubleshooting, those failures specifically in the Piper Seminole. We discussed general assumptions of electrical system failure and basic troubleshooting available for all airplanes. Brief overview of the Piper electrical system failure in the Piper and the warning signs, and troubleshooting the Piper electrical system. Here are my references, and thank you for listening.